In the next part of this lesson 6 here, we're going to be talking about callback functions. When I first started, I was really confused about these, and I honestly think that it's just because I never stumbled upon a good explanation, something that really broke it out into the pieces that I could understand. So hopefully in this video, I can do that for you and prevent you from suffering from that confusion for several months like I did. Now, the reason we're talking about this is because the built-in functions that we'll see later in this lesson are going to use callbacks or callback functions heavily. And if you don't understand them, you're not going to be able to use those built-in methods. So with callback functions, they're not any different from the functions we were writing in the previous lesson. Use the same syntax, so you can use the regular function syntax. You can use anonymous functions or arrow functions. It's all the same. It's just a different way of using functions, and it's just a little bit different way of thinking in general. To start us off, I'm going to paste in some code that we're going to actually understand by the end of this little lesson. So this would be an example of using a callback function. Go ahead and pause the video just so that you can take a look at it and get yourself acquainted. So I'll press enter here, and you can also simplify that code that we just looked at into this right here. So it does the same exact thing. You can see the answer is the same. And I would just pause the video and just look at those two code blocks just for a few seconds to just get your mindset around what we're doing here. Now, the entire reason that I'm walking you through callbacks here is because oftentimes you're going to see code that looks like the second option here, which is simplified, yes, and it's how I would write it, but it definitely does not display the concepts that you're supposed to be understanding very well. So in this section, I'm going to be writing code that I normally would not write just because it's a little bit longer form and more broken out than I would write it, if I was developing an application. But hopefully, that longer form of the code is going to clear up some of these concepts for you and really help you understand what callbacks are all about. So let's take a look at each of these code blocks. Let me clear the screen and just get us the main code block, and I have some comments pasted in here. So let me clear the screen and we'll paste this in here, maybe space it out a little bit so that we have some room to work with. All right. And if we look at this code here, there's a couple things going on. The first thing is we have two different functions here. The main function right here, and then the callback function. So oftentimes you'll see the callback function kind of just embedded within that main function. But in this case, like I said, I'm breaking it out for clarity. So this main function, it takes 3 arguments. The first argument is going to be some number. I just called it random number. It's arbitrary. And then should call. So this is going to be a Boolean value, which is basically going to ask whether we should go into the callback. And then the callback itself. So walking through this code, let's first look at result. So the result variable is going to be set equal to the random number. Now, what is random number? Now, of course, random number is a parameter to this function, and therefore whatever we pass in as the argument to the function is going to be the value of random number. So if we go to the bottom where we actually invoke or call this main function, you'll see that the random number is going to be 20 right here. So in this case, random number equals 20, and therefore the result variable also equals 20 because we're assigning it. Now, if we come down to this next part, there's some comments here that's not affecting the code at all. We just have a simple if statement. So we say if should call. So if you remember, we can pass a Boolean value alone. We don't have to put any equal signs or anything. And we can place that within a conditional to evaluate it. So if should call is true, then we're going to reach the code within this, this conditional block. If it's false, then we just skip this conditional block and we return the result. So basically, if should call is false, then we're going to skip this, and the result is currently equal to 20, and then we return the result, so the return of this main function is going to equal 20. But of course, it returns 40 as we see down here, so therefore the should call is true as we see here in the invocation of the function. Now, the last part is the tricky part. That's the callback. Now, the first thing I want to point out here is that callback, this name that I've given it, is entirely arbitrary. You'll see this very often. You might see either this as callback, or you might see the letters C and B for callback, and that's probably a convention that you're going to come across, but it doesn't have to be that way. You can call that whatever you want. It's just a normal parameter, but in this case, instead of passing in a number or a Boolean like we did for the first two parameters, we're actually passing in another function. So basically what we're doing is we're passing in a function to another function, and we're asking that parent function to execute the function that we passed in. In this case, my callback is what we've passed in. You can see in the arguments down here at the bottom. So we've passed in my callback, which has just been declared, hasn't been executed yet. And so callback right here is going to equal the declaration of this function called myCallback. So if you know how to run this, if we wanted to run myCallback, all we have to do is put these parentheses at the end and pass in some sort of number. And you can see if we execute this, we get 40, which is the same answer. Of course, that would be the more direct way to do this, but this is a contrived example that's hopefully going to explain callbacks to you. All right, so we've got this value called callback, and that is equal to a function data type that has not been invoked yet, so just a declaration. And we can basically call this just like this, but in this case, the callback is actually the function that we want to call. So we're doing that, sorry about that, we're doing that in this line right here. So if should call, that is true, so we get down to this code right here, and what we're doing is we're taking that function that's been passed in, and we are executing it with the random number parameter, which happens to equal 20. So we're basically doing what we did down here, but within the main function, we're letting our code actually execute the function. So we're setting that equal to result, which returns 40, and then we're going to return result at the bottom. So that's going to return 40, and that's how we've gotten to our answer. Now, like I showed you with that second example a little bit ago, it's a little bit more abbreviated way to do this, and you do not have to write a separate function called myCallback in order to, basically run a callback function. So what we could have done, in the first case, this is how we executed main function. We passed in 20, we passed in true, and then we passed in a predefined function that we had already written up here. But we could abbreviate this, so let me collapse this main part. And what we can do is say main function, and we know that we have to pass in a random number. So in this case, we'll stay consistent and we'll pass in a value of 20. We want the callback to actually be called within the function, so we need to pass in true as the should call argument. And then we need to pass in the function. So in the first case, we just put in my callback and it worked. But we also could do it like this. So we could write a anonymous function, and this function is going to take a number. So that's just the parameter that we're defining. And we know that if we go up to the main function here, it's going to pass in this random number as the argument. So that's what number, or num, is going to represent. And then we have to break it down here, and then we have to return the num times 2, which is going to ultimately return us 40. And that's another way that we could write that callback. There's other simpler ways. So we can also do it like this. So let's do main function, pass in 20, true, and then in this case, let's just put in an arrow function. So we have num, and then we use our arrow function syntax, and then we return the num times 2, and once again we get 40. So just another way to pass that in. And we can even simplify this a little bit more. So we can pass in the same parameters. We don't actually need these parentheses here because it's a single argument. So we'll take num, and then we also don't need to break down onto the second line. We can actually just take num times 2, and that's going to return it the same way. And now we've gotten our answer of 40 once again. So as you can see, that's how we get from the most contrived, simple, elaborate example to the code that you're probably going to be seeing in a lot of examples. This is what a lot of people use because it's just a much simpler, quicker way to write a callback function. So hopefully this section, I know it's a little bit confusing, but rewatch it again if you are not totally clear on this, because we're going to be going into the built-in functions that use these callbacks very heavily, and it's going to be important that you understand how they're working. So you might understand callbacks now, but why do we actually need them? They seem overly complicated, don't they? Well, the reason we need them is, in my opinion, this is just based on experience and just observation. The two things that it enables is reusability and asynchronous programming. Now, I'll talk about each of these. We're not going to go too much into asynchronous programming in this video for reasons I'm about to explain. But let's start with the reusability thing, and that is going to be crucial to really connecting the dots when we get into some of those more advanced array built-in methods that we're talking about later in the lesson. To really understand the reusability thing, we're going to look at a common array method that's called map. So we're going to look at this a little bit later in the video too, but I really want to show this as a lesson of why we need callback functions. So what this map method does, if we look at the documentation, is it creates a new array populated with the results of calling a provided function on every element in the calling array. So it's basically doing a transformation, and you're able to define the function that has all that logic to figure out what it's doing to each element in the array. Let's take a look at a very simple example. Now, this isn't going to make total sense, but it will kind of connect the dots from what we just did with that original callback example. So what I'm doing is constructing an array, very simple one at that, and then I'm going to define my custom map operation, and we'll just say callback. So we want to be very specific with what this function represents to us. And then the parameter is going to be the item from the array that we're mapping over. And what we're actually doing here is we're kind of iterating over the array. So when we get each element of the array, which is going to be passed in as an argument into this function, we want to return a value. And that value is going to be the transformed value that will kind of occupy the new array that we have. So we're going to take the item from array and we're going to multiply it by 2. So we're basically going to take this entire array up here, and for each element we're going to multiply it by 2. So we've got that function defined. So far it's not really doing anything, but if we take my array and then we need to set this equal to a new array, because the map method is going to actually return the modified array. It's not going to modify the original array. So we're going to take my array dot map. So we're just calling the function that's built into our array, and what it requires is going to be a callback function. And in this case, we've already defined that, so we're going to pass in my custom map operation callback, and then we're going to execute it. Now, if we look at the new array, you're going to see that every element has been doubled. And what it's done is it's looped through, it started at 2, then it's taken that value of 2, multiplied it by 2 to get 4, so on and so forth. So you can see how we've kind of iterated over the array and applied some sort of transformation defined by our callback function. Now, here is where we really understand this concept of reusability. So in this case, sure, it works, we're multiplying something by 2, but it doesn't really convey to us why this callback is so useful. Now, when the creators of the JavaScript programming language introduced this map array, what they wanted was to enable the developer to use this same method for a variety of use cases. So what if we had an array that was full of strings? So let me copy in a new array here. I need to name it something different. So we'll just say string array. And this is going to have a bunch of strings in it. And you might say, okay, well, I need to find a different built-in method to map over this and do some sort of transformation. Well, because we have a callback as one of the parameters of this predefined function, we have a lot of flexibility. And instead of looking for a new method, we can just redefine our custom map operation. Now in this case, I'm not going to do it longhand like we've been doing. I'm going to show you the shortcut. So we'll say, not my array, but the string array, which we just defined. We're going to call the map method on it, and then we're going to pass in a callback function. So let me template that out. I'm going to have an arrow function right here, and what I'm going to pass in is going to be the item from the array. So we'll just say item from array. We don't need any parentheses around that because it's a single argument. And now the transformation that we're trying to do, so if we do this on one line, whatever is right of this arrow is going to be returned from that function. So all we have to do is transform it in some different way. So maybe we wanted to construct just the first letter of each of these words. So maybe we wanted a new array that has the letter H, W, M, N, I, and Z. All we have to do is maybe return the item from the array, and actually what I'm going to do here is pass in, no, I don't need to. I'm just going to take item from array, and then I'm going to give it the 0 index, because you can access the first letter of any string by using the 0 index, second letter by 1, third by 2, so on and so forth. So you can see that we've returned the first letter of each of these elements in the array, and we did this for an array of strings by just redefining that callback function. So that's the value of these callback functions. It enables us to reuse the same function over and over again, so in this case the built-in map function, and kind of modify it for whatever needs that we have. And we can do something way more complex than just multiplying by 2. We can have conditional logic in here. We can say, you know, if the number is prime, then we want to multiply it by 2. If it's not prime, then we just want to return the number itself. You know, you can do all sorts of different things with this, as complex as you want it. All right, so I think you probably understand why callbacks enable reusability, why they're important, you know, how they work, all that kind of stuff. Now let's move on to the asynchronous topic. So I told you that callbacks enable asynchronous programming, and what that gets us into is a whole nother topic that I'm only going to briefly touch on here. So when I say asynchronous, all I'm talking about is code that does not run immediately. So with the code that we've run here on this screen, you'll probably notice that when we press enter, it executes immediately. It pretty much seems instantaneous to our human brain. Now, there are times when we're writing code that it might even take up to 2, 3, or 4 seconds for a piece of code to execute. And a good example of that is, let's say our application database that stores all of our data is, you know, in a different continent from where the user is actually clicking. So maybe I host my database here in the United States, but someone from, I don't know, Italy or something is visiting my web app and has to access the web app from their browser in Italy, and so it's going to send off a request to my server and then to the database, and that request to get all of the information for that web app and perform different functions is going to take a certain amount of time, and it's not instantaneous. So we have to handle that with our programming, and you might just say, well, okay, let's just wait until it's done and then execute the next line of code. Well, in that case, with a web app, you're going to have multiple asynchronous operations going at the same time. So you're going to have multiple calls to a web server that are going to take, you know, half a second, 1.5 seconds, maybe even a little bit more. And if you added all of those together and you just did it in order, your web app is going to take 30 seconds to load. And in that case, nobody's going to use it. So we have to run all of this code kind of at the same time. And for that reason, we have asynchronous programming, which basically allows us to run some code and then run other code while that previous code is still running. Now, I know this kind of gets into the topic of like threads, execution threads on a computer. It's not really what we're talking about here, and I really don't want to get into all of the details of this. But as we go through this series, we're going to be talking about asynchronous callbacks, promises, and the newer ES6 async and await. So these are all different ways that we can write asynchronous JavaScript code. You'll see how it comes into play a little bit later in the series. In the next part of this lesson, we're going to be talking about primitives versus objects in JavaScript.